So hello everyone. Working for ISCF has been the great learning experience since in the beginning. We started sometime late 2021, early 2022. And during the initial time, I started with the small project of gesture-based robotic arm control. And then I slowly progressed towards emotion-based robotic control. The main idea is to enhance safety in human-robot collaboration. And for that, we need to have the in-depth understanding of the human so that we can bridge the gap and make the collaboration more like human and human collaboration rather than human or robot or human or machine collaboration. So this robot is programmed for basic gestures. So if I swipe left, it will go to the pose 1, and in the next round I'll do a different swipe just to control the robot. So these are the predefined gesture which move the robot to the predefined positions. To progress further and to understand emotions better, it's essential to have second confirmation, and that second confirmation comes from physiological measures. To capture these physiological measures, we have set up this integrated human-robot collaboration cell where the human and robot are collaborating, as well as there's a robot-robot collaboration and human-robot collaboration. And during this time, there are several sensors which have been put on the participant, such as EEG cap, which gives the data, and there's a eye tracker device which tracks the eye tracking of the participant. Also, this is capturing through Empatica device, heart rate, skin conductance, body temperature. All this go towards the emotional side of the thing. And there's a tracking of the human body skeleton. In this particular setup, I have integrated several sensors. EEG is one of the sensor. Empatica device another sensor which is responsible for ECG, heart rate, skin conductance, and ETA data. I have also integrated Tobii eyeglasses to track the eyeball and gaze movement of the participant. I'm also capturing the spatial movement of the participant. The top camera captures the different devices and its location within the environment. Eye tracker data and top view and these cameras are the part of the situational awareness data, whereas other integrated devices are the part of emotional awareness data. Out of this study, I have successfully captured data from 38 participants, each participant having 6 gigabytes of data roughly. This is a huge data to be pre-processed, analyzed, and a final emotion recognition model would be developed based on this. Another aspect of ISCF project was our testbed. Flexible gripper is one of the testbed we have worked at Cranfield. We have got 2 industrial partners on this, and more of this would be talked from Dr. Seemal.
As part of the Smart Cobotics PA1 project, we have made exciting progress in human-robot collaboration at Cranfield University. Our robotic cell can now adapt to human emotions and gestures, making interactions smoother and more intuitive. We have integrated physiological measurement devices on the robot, which help the robot to respond more naturally to improve the workplace safety. Our research in emotion recognition using AI has given us valuable insight into how robots can understand and react to human states in real time. We are also studying trust in human-robot teams, focusing on workload stress and safety. Plus, our feasibility study on the large-scale gripper is helping us to handle irregular objects more effectively. With our ongoing research and publications, we are shaping the future of smarter, safer, and more adaptive industrial robots.